Good morning, this is Sarah Parker and I'm going to do my code explanation for CPSC 5010 assignment 8. This is the first part of the assignment, which was to create a point class and a circle 2D class. And so for the first thing we were asked to do is to create a point class, which is this one right here. In the point class, we needed two double fields, X and Y, with get methods. So I added a default constructor that would automatically set X and Y to 0, or we can use a constructor that requires parameters of X and Y if we want to set a point to something other than 0, 0. And I created a destructor as well. And then we have our get methods, get X and get Y, which will return that value of X and Y from up here. This class is going to be used in the Circle 2D class. So for that, we want to include the point.cpp file. That way it can find it from here. And then we also created a definition for a constant, which is our pi, which is, I did the full pi, but you could just really do 3.14. The first thing we were asked to do is a point data field named center. So this is where we're going to call this object of center from point. So point, and we're naming it center. So that's going to be our XY, the center of our circle. And then we were also asked to create a radius data field, and so we have that one here. For our constructors, I have a default constructor which will set center, this point object right here, to 0, 0, which we could actually just leave that 0 because we have a default constructor as well that would set it to the same thing. And then we're also setting our radius to 1. We have another constructor that takes in parameters, so our x, our y, and our radius. And this is just saying that if our center is at 0, 0, then we're setting point to 0, 0. Otherwise, we're setting point to x, y if our x and y is not 0 and 0. And then our radius, we want to make sure if it was set to something less than 0 that we set it to 1. Otherwise, we set it to radius. I have a destructor here as well. And then we were asked to set a method called getArea, which will return the area of our circle. That's using our pi times our radius. Another method to get the perimeter, which is getPerimeter, which is 2 times pi times the radius, just basic mathematic equations. And then we have a method, we have 3 Boolean methods. The first one is going to check if the point is inside the circle. So if we have a point, we're going to check to see if it is inside our circle. And we're doing that by using some math equations where x minus the center of get x, so that x that we set for our center object, and then we're going to take that to the power of 2, and we're going to do that for the same of y. And that will tell us if our point is inside the circle based off of our radius, using this equation of our power and radius to the second. The second one is to see if another circle is inside this circle. So we're taking a reference of our circle. We're basically creating an object of circle, using it as a reference, and putting it into our Boolean method, and then checking it against a new circle. So we'll see if that circle is inside the current circle. And then overlaps, we'll do the same thing of taking a reference of our circle and seeing if it overlaps with the current circle by using this equation. So then we were asked to test it by using specific parameters. So the first one is circle 1 by using a parameter of xy, 2, 2, and a radius of 5.5, 4, 5, 10.5, 3, 5, 2.3. And then we're going to output the area, the perimeter, and then we're going to see if it actually contains it or overlaps it. So we can go ahead and run this program. I don't feel like that right. Let's try it again. There it goes. Not sure exactly what's going on. We'll see. We don't really care about debugging it. Oh, and we're not using Java, so that shouldn't be an issue. Let's go back up here. All right, let's see. Let's close all this out and let's try again. Getting all sorts of errors. It looks like it's just really slow in trying to build it. All right, let me pause the video while I debug this real quick and we'll see what's going on. Apparently I didn't pause it. So you got to just sit here and watch me while I debugged it. Okay, well, there actually wasn't any debugging that needed to happen. For whatever reason, it was just my build that wasn't working. So I'll just walk you through it again now that you already watched me, but I wasn't explaining anything. So sorry about that. Okay, so I'm just compiling it manually. I'm in the folder where this is. It compiled just fine. So now we're going to run it. And there we go. So the area of circle 1, the perimeter of circle 1 contains the point. Circle 1 contains circle 2. No. Does circle 1 overlap with circle 3? Yes. So we tested our program to see if our circles were, if circle 1 was inside circle 2, and it was not. But it did overlap with this third circle that we had created. And then we just have our perimeter and our area to show that those functions work as well. So this program does work. Sorry about the big gap, the big blank space in this video, but let's move on. I'm going to go to the next one, which is our person file. Okay, so for this one, this is the second assignment, and this is our person. So essentially, we created several classes and derived classes. So our first class is person, and all of the following classes are subclasses of person. The first one is student, and then from the other, we have let me start over. We have two classes derived from person, student and employee. And then from employee, we have two derived classes, faculty and staff. So the first thing we were asked to do was on person. Let me see if I can open this folder a little bit, because that will just make it easier. There we go. Okay. So I did create header files for this assignment. So this is my header file for person, and we have class person, and then we were asked to give each person a name, an address, a phone number, and an email address. So this was my constructor, my destructor, and then each class will have a virtual abstract function that will be overridden and more specific. But this is our virtual function output. So then in our implementation of this, I set the name to name, address, phone number, and email to those variables. We have our destructor. We don't need to use it. We don't have any dynamic memory being used. And then for our output, we want the name, the address, the phone number, and the email address to all be output. So from there, we go to student, and our student header file, student header file. Our student has a class status, and and that status was supposed to be defined as a constant. So these are the statuses: freshman, sophomore, junior, and senior. So we add status into our constructor, and then we have our destructor, and then we also are going to be using that output method. So for the implementation of this, we have our constructor, and we've added status. And then because this is an extension of person, we're also going to be making those variables the same. And then we're adding status to status. And then for our output, we're calling our person output because we want it to be the same as our person, but we want to add their status to that output. So down here, we're defining our constant variables. So we can call this variable from outside. So if we call student freshman, then it will replace it with freshman. And that's what we're going for right here, is we're making that a constant and then replacing it with this string. And I will show the implementation of the whole program in a minute. So from there, we're going to employee. This is our employee header. Each employee has an office, a salary, and a date hired. So this is our office, our salary. We are calling an object of my date, which I'll go to the my date class here in just a second. And then we're adding that in here. My date has to be a reference of the object in order to be called in. And then we have a destructor, and then we have our output override. So for employee, it's the same thing. We're adding office, salary, and the date that they were hired as a reference. And then as an extension of person, the same as the name, address, phone number, email address. So that's just setting those variables back to our person. We have our destructor, and then we have our person output. So we want that to be the same, but we also want to show the office, the salary, and the date they were hired. And to call date hired, we're going to call that object of my date hired, from up here. And we're going to use the display function. So in order for that to make sense, we're going to go over to my date. This is the header. So my date is an object. So it's got private variables, day, month, year. We have two constructors, one that's just a default and one with parameters, and then our getters and setters for set day, month, year, and get day, month, year. And then we have our display, which is what we were using in our previous class. So the implementation of it is going to look like this. The basic constructor, we're just setting it to January 1st, 2025. Otherwise, you can input a month, day, year, and then we're going to set those or return those. The display, we want to make it a set width and a set fill, and then output the day, the month, and the year. So that object is what was called in our employee. And then the display method is what was called here as well. So from employee, we also have faculty and staff. So faculty header, faculty has an office hours and a rank. And so we've added that to our constructor as well as the my date, because faculty is an extension of employee. Sorry, it's an extension of employee, which is why we include our employee header up here. And then we also have our output override. And then the implementation of it is the same. So it's all of the same parameters that we were using, plus what we were using in employee. We added office hours and rank, and then we added that in our output. So we're using our employee output this time, which was from here. And our employee output is still using our person output. We're just one level lower. But now we are, let me go back. We're also adding office hours and rank. And then the last one is for just a staff employee. And a staff employee simply has a title. And this is still an extension of our employee class, which is also an extension of our person class. So we added the date that they were hired and a title. We have our destructor, and then again, we have our output method. So in our constructor, we have added their title here at the end, and then also we are assigning those variables to our employee constructor as well. We have our destructor, and then the only thing we need to add is our title. We are still using the output from our employee class. Since this is a derived class, it can call from there. So we have all of the classes. Now we want to test them. So we make sure that we are including the actual CPP file for all of our classes that we have created so that it can call them. And the first thing that we did is create a person object. So our person object only requires a name, an address, a phone number, and an email address, and then we will call that output. The second one is our student. So it requires the exact same things as our person, but it also requires their status, which was senior. So this is where we're calling our static constant senior, and that should add the string of senior to this parameter, which will then output appropriately when we call the Lindsay student object. An employee object, this is where we needed to start creating our date object. So I created a date object with the employee's name and then the date that they were hired. So this is where it calls all of our regular person object, but then remember for employee, they needed an office, a salary, and the date that they were hired. And so we're calling this object that we created here, and then that will get put into our output. Then we created a faculty object. So it's the same thing. We created a date hired for this faculty member. And then we have our office, salary, when they were hired, but now we're adding office hours and their title, and then that will all get put into output. And then for our staff one, it's the same thing. We created the date that they were hired and then passed that into the parameters and then their title. So we are now going to run the program to see what this all looks like. I'll try to run it this way, and if not, then we will just do it the other way. So far, so good. Okay, here we go. So our first one was just our person. So we have name, address, phone number, and email. And then our second one was our student. So it added our student status senior, and that was from calling that static variable. Then we have our employee, which now we have added their office, their salary, and the date that they were hired. And then we have our faculty object. And so now we have added office hours and their rank. And then for the last one, we have our staff, which also has the date they were hired and their title. So all of these worked the same, and this was accomplished by overriding that virtual abstract and making it specific to that class. So this was a fun one. I actually really enjoyed making this and learning how all of the classes interacted with each other. But if you have any questions, please let me know. Thanks for watching.